without break. Bonjour. Sorry for my Polish. Welcome everyone. I hope you're doing fine. I'm very happy today to introduce Marcin Wylot, who was one of my PhD students and is graduating now, as you know. My name is Philippe Moreau. For those of you who've never met him, I supervised Marcin for about 4.5 years for this PhD.
Almost. Almost.
So the process will be extremely simple. Marcin will give a presentation for about 40 minutes, as far as understood. Then you have to ask him like nasty questions, right? That's the last opportunity for us to ask the nastiest questions on the research topic. Then there will be extremely short official part where we'll hand him some documents, and then I think there will be an apéro.
Yes, there will be an apéro.
Super. So without further ado, Marcin, the floor is yours.
Thank you very much. Thanks a lot, Philippe, for the introduction. I'm happy to have all of you here. I'm happy you found time to come and to see my performance, my show. So let's the show begin. The topic of my thesis was efficient, scalable, and provenance-aware management of linked data. But today we will actually focus more like on linked data. Let's start with a small quiz to see what you know about the domain, etc. Don't laugh, you have to ask this quiz. So who knows linked data? Who knows what's linked data? Okay, already not bad. Big data and 3Vs. Okay, even better. I like the audience. Semantic web. RDF. Data provenance. Okay, now we are going a bit. Life is about links. We create links between each other. We create relationships. We meet people. But we create also links with objects. I own this phone. This phone is connected to those headphones. The web, the internet, is also about links. Currently, the web of document has just links between documents. So we have a huge document, and we have link to another document. We can read those documents, but they need to be read manually. So there has to be a person, a human being, reading those documents and understanding the information. The web of documents is primarily created for human beings. It's like silos of data, of silos of information. There is a huge silos where you have a lot of information. You can extract this information. You can find this information, but you need to put your diving equipment, yellow submarine, and we dive, we swim in this information. Of course, we can do that. We can spend the weekend searching for information. We can check Facebook. We can check governmental sites. We can check all statistics. If we need some crime data, if we need some weather data, climate data, Wikipedia, it is there. The problem is that I'm not sure how about you, but I'm not happy spending whole weekends trying to swim in this information. I would prefer to go to the gym, to the mountains, do some cool stuff like skiing. How about we create links between pieces of information, between pieces of data from those huge silos of information? How about we extract things and build meaningful connections between those pieces of data? And that's what's linked data about. With linked data, we create meaningful relationships, meaningful links between pieces of data. It's like a global database. So you have whole internet, and you have things, pieces of information, pieces of data connected together. Like web of documents was primarily created for human beings. Some human being has to read it. Then linked data is more created for machines. It's still understandable for human being. It's not a problem for us, but it's mostly created for machines, so that machines, they can process this data. We primarily distinguish things in linked data, objects, resources, and links between them. Those links, they have semantics behind. So the link means something. But how does it change our life? Let's say I have a friend, Jill, he has a company, or he wants to start his new company, and then he also wants to find the right place, right location for his company. So he would like to know what is the taxation, what are the prices in the region he wants to locate his company. He wants to know salaries, unemployment, climate, whatever. He can find this information. You will spend your weekend diving in all this information. I will send you some pictures from the mountains, sorry. No, I will not send him pictures from the mountains. I'm moving to another country. And I'm a guy who kind of likes to have stuff organized. I like to prepare such kind of situation like moving. So I would like to know which mobile provider I should choose, what bank account. I would like to find some cool neighborhood to live in. So I will be the same weekend you will be spending looking for your taxation data, information. I will spend looking what's the situation in the country I'm moving to. Let's say we have a video. This talk is actually recorded. And we will put it on YouTube, cool. And then in 10 years, we will also put some short bio of me. In 10 years, somebody will see this bio, it will be totally outdated. How about we annotate this video with a link to my personal website, so that whenever somebody sees this video on the site, he also can see the information of me, my current bio, my current affiliation, and what I'm doing currently after 10 years from now on. It sounds a bit maybe like futuristic, but there are already living projects working with this data, living applications of linked data. Linked geodata, those guys, they try to take spatial data and put it to linked data cloud, connect it together. It also interlinks to external knowledge bases, so it's not like it's just a small piece of data isolated, it connects outside. Clearer Status is a platform which combines data information about ozone and visibility, and it connects it with corresponding geographical information. So we can visualize it, what's the climate, what's the ozone and visibility situation in particular places in the US. Moreover, if we click on one of those circles, we can fetch additional information about the place. This is a project from guys from Derry, Galway in Ireland. Here, they basically bring together all real-life data about planes, traffic, trains, all together. They linked it with static data, and they visualize it. You have a plane, you can see the information about plane, and this data is really live. You can go and you can really see this information moving live. There is also a Swiss example. It took me a bit of time to find this one. This is a catalog of Swiss libraries. You have all positions from Swiss libraries, all books. You can find them. You can see on which library you can find this book. Moreover, it links outside, it links to the publisher so that you can check what's the book about. I have this narcissistic tradition of putting a picture of myself on the slides. So that's the slide. This is a talk I gave 4 years ago in Germany. It was recorded by video lecture, and they tried to provide a link to my profile. It was just, they just copy-pasted something from Google. Guess what? This page is already outdated. How about we annotate a video with my personal information, with the we link the video with my personal data so that during the presentation, during watching the video, the information can be fetched automatically, and it's current information. This is an example from the British Parliament. The guy is giving a speech, and during his speech, they fetch data from national government data from the UK. This data is always up to date. It's from reliable source. We know it's current. We can trust this data. The picture here shows data sets that have been published in linked data format. You can see almost 10,000 data collections put together, interlinked together. Those data collections, they were produced by totally independent contributors. So linked data describes methods of publishing semi-structured data in the web. The data published in linked data should be interlinked. Linked data builds on standard technologies, on standard web technologies. It's not like there is a current web and there is linked data. No. Linked data extends current technologies to publish information which is linked and which can be processed by computers. The data becomes machine processable. Moreover, machines, computers, algorithms, they can take actions based on the data found in the internet. Everybody is talking about big data, so I also want to talk a bit about big data. Big data is a pretty broad term. Big data is about data which is high volume, or high velocity, or high variety. Big data is a data that cannot be handled with traditional methods. And linked data is also big data, and it's big data from all three dimensions: volume, velocity, and variety. Volume, because it's huge. You have a lot of data connected across the web. It's like a global database. It's about velocity. You have those streams, you have those sensors, traffic, cars, planes. You link this to the static data. You have very fast streams of incoming data. And variety, which is my favorite one. This was basically the focus of my work. The variety can be divided into two sub-dimensions. First of all, linked data is semi-structured data. It means that, like with traditional database systems, you have a table, you have a name, surname, address, phone, whatever. There was a strict structure. With linked data, you do not have a strict structure. You have some structure, but all elements in linked data can be different. I have name, I have surname, but I don't have phone. I don't have permanent address, let's say. Linked data is also heterogeneous data. Since we are linking all those collections of data from the web, the data is very heterogeneous because it's produced by institutions which are totally not supervised, not correlated together. And since with linked data we integrate a myriad of data sets across the web, we need to somehow establish a transparency, because if we produce a result from that kind of data, a user who will see the results, he will be like, okay, but where the answer comes from? I don't know. I'm puzzled. I have no idea. So we need to provide information how the result was derived. And that's where provenance comes. So data provenance is information about entities, activities, and people involved in producing a piece of data. It tells us which pieces of data and how are combined to produce our result. So the lack of structure and free integration of data across the web brings new challenges to databases. Those main aspects, like unstructuredness and heterogeneity, were focus of my work, of my 4 years of PhD studies here. We analyzed and evaluated different linked data management systems. We found their weak and strong points, and we figured out that there is still some space, some room for improvement in terms of performance and new features. So to solve this problem, we defined 3 research questions. The first one is how to efficiently store vast amount of linked data. Here we propose a data partitioning algorithm, system architecture, data placement techniques, and strategies to load and query data. The second question was how to store and track provenance information in linked data. So here we started with providing a way to express the provenance of query results. We leveraged the notion of provenance polynomials. Then we proposed storage models to store this information, and then query execution strategies to compute those polynomials. The last but not least question we tackled was how to efficiently support queries tailored with provenance information. And query tailored with provenance information is a query where we execute our query, where we want to retrieve get our results, but we also want to filter the data we want to use to get those results. Here we started by a theoretical definition what provenance-enabled query is, so query tailored with provenance information. Then we proposed 5 provenance-oriented query execution strategies and some extensions of storage models and indexing techniques to handle those queries. To put our contributions in a nutshell, we proposed data collocation and partitioning techniques for efficient and scalable query processing, and we made it the first efficient provenance-aware database for linked data. There is some technology stack you should understand to be able to follow, so let me give you a super brief introduction. URI, RDF, Sparkle. So URI is a uniform resource identifier. We use URIs to identify things in linked data. So my phone has a URI. I have a URI. This is my URI. My headphones, they have URI. So this is basically an identifier. RDF is a standard model for data interchange in the web. So it's basically a data model we use in linked data. The basic element, the basic statement in RDF consists of subject, predicate, and object. All of those elements, all of those resources, they are URIs. There is also a query language for linked data. It's called Sparkle. For those of you who know SQL, that's quite similar. Maybe not exactly, but I always say to my students, if you know SQL, you can learn Sparkle pretty fast. For those of you who doesn't know SQL, query language is more or less like if you type in Google what you want to find, and it gives you some results. Now I can move to the technical part of the presentation. The menu is as follows. First, we will quickly go through linked data management system, then our techniques for storing and tracing provenance, and at the end, we will move to querying provenance information. Let me introduce you Diplodocus, a new distributed linked data management system implementing a novel hybrid storage model based on flexible RDF templates. The architecture of our systems based on 2 kinds of nodes, master node and worker node. Master node is like a boss. It's the one who receives your query and returns your results. We can distinguish 3 main components in master node. There is a key index, which basically translates URIs to IDs, to numbers, because computers, they like more numbers than strings. There is partition manager. It's a divide and conquer guy. It basically takes your data, it cuts it to small slices, and then it sends it to workers. And then there is a distributed query executor. It's like a manager. It takes a query, it does a bit of massage on this query, and sends this query to workers so that workers they can do their tough job. And then workers, they store data like pieces of data they have. They store local indices, and they basically do the work. So they receive information from the master node, they receive query from the master node, they answer the query, and they send results to master node so that master node can send it back to you. The main idea of storing data in our system is collocation. We proposed a new hybrid model of storing data. We consider linked data from two perspectives, horizontal and vertical. Horizontal is a graph perspective. Here we propose so-called subgraphs, small molecules of data. And the vertical one is like a list of resources indexed by types. In Diplodocus, we collocate different data together so that we can answer queries faster. Let's now move to storing and tracing provenance. We investigated 4 different models for provenance, like storage models. First one, the easy one, is the annotated model. Here we basically annotate all elements with provenance information. But this is not really efficient from storage consumption perspective. We can also collocate data. One extreme option would be to collocate all data based on provenance, but that would split, those our small molecules, and that would defeat the whole basic idea of storing data in Diplodocus. But we can also collocate data inside those molecules. We can collocate data based on predicates, and we can also collocate data based on objects. So having the storage model for linked data, for provenance in linked data, now we can move to provenance polynomials. The question here we asked ourselves was how to represent provenance information for the user. There has been a lot of theoretical works on provenance, including those for linked data. Here we leverage a notion of provenance polynomials. Our goal was to provide transparency of results, so that we need a solution to characterize ways each piece of data contributed to the results. We need to pinpoint the exact piece of data to the result, and we need to trace back the list of pieces of data and the way they were combined to deliver the result. So we implemented an algebra for representing how pieces of data are combined to deliver the result. This is a simple example of a pretty simple star-like query, and the polynomial here shows us which part of query was resolved using which piece of data. It shows us with those operators how the data was combined, how were the unions organized, and how were the joins organized. From our experiments, we can say that tracing provenance introduced some overhead. It was about 60–70% in query execution time. But it seems to be an acceptable price for a very detailed provenance trace. We also noticed that the storage models we investigated behave differently depending on structure of the data set, how heterogeneous or homogeneous it is in terms of provenance, and the workload we want to execute. Now I can move to querying provenance. There is a pretty cool story behind this part of the work. So when I was presenting the previous part at the conference, I think it was Seoul last year, the chair of the session asked me a question, but Marcin, why you don't include provenance information in the query execution? Okay, that was a good question. I started talking with Paul, he co-authored both of those parts of the work, about this provenance stuff and if it makes sense, etc. And Paul asked me a question, can it make query execution faster? Okay, when it comes to performance, query execution, databases stuff, I came to Philip, my supervisor, and then we started talking about all those databases stuff, like, indexes, pruning, collocations, etc. And then after a few sessions of brainstorming, we said, like, yeah, it makes sense, it can work. So that we started working on provenance-enabled queries. Provenance-enabled query is a pair of workload query and a provenance query. Workload query is a typical query user wants to execute on a database. So it's what you want to ask the system. A provenance query then describes attributes of data we want to use to derive the answer of the query. So it tells the system what data it should use to answer your query. Provenance-enabled query provides results of a workload query using data, only data described in the provenance query. Let me give you some examples for better understanding. So here we want to retrieve titles of articles about Obama. This is our first green workload query. But we want to use only data from sources attributed to government. This is our first blue provenance query. But provenance is not only about source of the data. So the second provenance query specifies us that the data is somehow associated with a senior editor or a manager, so it gives us more detailed, more exact specification of the data. A general idea of executing provenance-enabled queries is as follows. As an input, we give to the system a workload query and a provenance query. Then the system, a database, produces results of both of them independently, and after that, we join them to retrieve results of a workload query sourcing from data described by the provenance query. Unfortunately, such simple post-execution strategy would, of course, result in poor performance. In our methods, the query execution process can vary depending on the exact strategy, and we proposed 5 of those strategies. Typically, we start by executing a provenance query, then we optionally prematerialize or collocate some data, and then the workload queries, they get rewritten by taking into account the provenance information, the data, the results of the provenance query, and then finally we execute the workload queries. And the process, as a result, gives us the results of the workload query sourcing only from data described by this provenance query. From our experiments, we can say that querying provenance data does not necessarily introduce a performance overhead. Moreover, queries tailored with provenance data can be executed faster. The reason for that is that provenance information is pretty selective, so we can clean the intermediate results before actually inspecting them in details. That would be the end of the theoretical, technical part of this presentation. Let's now move to the lessons we learned. So first lesson we learned is that there is still room for further improvement in linked data management. Collocation and specialized indices seems to give us the right direction. Provenance overhead does not have to be high, so we can afford the transparency here. What's more, we can leverage provenance information to improve provenance. That leads us to the prospective future of linked data. The future is as follows. We have data in the internet, which is linked, which is integrated, and which gives us results, and those results are transparent. We can trust those results. We know how they were produced. To sum up, we proposed data collocation partitioning techniques for efficient query processing. We implemented cloud support for scalable query processing. And then we made it the first efficient provenance-aware linked data management system. That's our way of tackling the problem of efficient, scalable, and provenance-aware management of linked data. Thank you very much for your attention. If you have any questions, I shall do my best to address all of them. The apero is waiting downstairs.
Okay, so I hope that you are now all experts in linked data and provenance. There will be a quiz at the end, don't worry. We have time for questions, so don't be shy.
If not, we can talk with wine. It really facilitates.
So I know very little about provenance and linked data and things like that, but how does the provenance query work? Do you assume that the user knows what the possibilities of provenance are, or do you somehow visualize what those possibilities are, and then they can sort of
kind of assume user to have some kind of knowledge of the underlying data he or she wants to use in query execution. So it's not like we expect him to know the data he's using. At least attributes of the data. It might be not like, so provenance generally in linked data is kind of defined. There is a specific ontology without going into details what's ontology. So the properties which are used to describe the provenance, they are standardized. So it's not like it's from nowhere. There is a Prof.O model actually proposed by Paul, one of the co-authors of those papers. And it's there.
But then it seems that it severely limits the exploitability of this notion to people who are familiar with the ontology that's driving it.
That's partially true. So it's a bit like with SQL. Who writes SQL queries? People who somehow know what they are asking for. And then they create applications for end users. End user works with the layer which is behind. So end user can see the results of the query, and then can see the provenance information because the developer wrote those queries.
See, I have a fundamental issue with that in the sense that there shouldn't be this middle person. Right? The user should be the one who can, and for me, it would seem interesting to visualize the possible provenance. And then me as a user can say, I want newspaper articles or government sources or tabloid papers if I really want that.
You can do that with the provenance polynomial. So you execute your query. You can discover the provenance. So you execute your query, like standard query. Then we provide you provenance polynomial, and based on this provenance polynomial, you can then filter a bit like your query. So it would be two-stage process, but it's definitely possible. Thank you. You're welcome.
Yeah. So you started your talk with life is about links and structuring linked data. So as you, I do not like to miss a lot of time searching something on the web, but my queries are a bit more difficult than just asking your surname or your whatever characteristics that I want to know. Let's say I want to know something about financial situation of Greece or the relation of Switzerland and the EU. And now it gets a bit more messy. How do you deal with these kind of queries in linked data thing? Then you have problems with correctness, interpretation of data, and security. Can you somehow deal with that in your linked data world?
So first of all, linked data is, you can see it a bit as a mess.
Yeah.
So you have, but it's a good mess. It's not a bad mess. You have Switzerland, and you have some properties around Switzerland. You have Switzerland is not a member of the EU. Switzerland signed some agreement with EU. The agreement then links to some specific details about the agreement. Then details can link somehow further. So it's like a graph. You basically do steps in a graph. Of course, to extract this information, well, this should be done. there are techniques like machine learning algorithms, entities extractions, even crowdsourcing.
And when it comes to more complicated things, I mean, yeah, you may have in your graph the articles or contracts and whatsoever, but I mean, is this really the important thing when I have a query like given the financial situation of Greece, something like that? So more like what happens now with Greece and
this is, I would say, this is a kind of
is life
query question. You basically want more like an. Are you looking for numbers or opinions?
Numbers, opinions, and so on.
So if you are looking for numbers, then you are linked to statistical data.
Okay.
If you are looking for opinions, you can be linked to blog posts, to forums, to some tweets.
But then it's my job to really digest that, read
it's
that,
your job to
summarize
interpret,
that,
to make some interpretation.
That's not your system that can
Or-
provide me some kind of.
Or what you can also do with linked data, since it's machine processable, you can write a simple application which will make the interpretation for you using the linked data, and will like gives you some decision support hints. But this is like, you know, on your side to make the interpretation side.
Further questions? Yeah.
My question is related to the first question. So you mentioned there are standards for provenance. So how widely accepted are these standards, and how what's the part of this whole linked data graph that you showed that is somehow has provenance information?
So first of all, Prof is an official standard, like under the umbrella of W3C organization. So it is official. In terms of relevance of provenance in those data sets, as far as I remember, it's around 40% of elements they have some information about provenance. It's something like almost 40%. So it is there. We can reuse that.
Further questions? Everything is clear?
I like it.
Super. So let me just now say a few words about Marcin before giving him some document, I guess, waiting for. So Marcin was one of the first members of my group, XI. So he saw it a bit, you know, grow from a few people. We were like, what, Janelle, Gianluca, and you before that time. And he saw a bit the, you know, the progression of XI from a small group to a small powerhouse of research papers. And for me, it was really the same with Marcin, right? I saw him kind of, you know, evolve in 4 years. And Marino, who speaks perfect Polish, it seems, told me this morning that Wylot in Polish, it has some kind of connotation in terms of flying out or taking off. I don't know, the Polish people in the room, you should correct me if it's wrong or not. The Polish airline is actually called LOT, right? So there is this also this kind of connotation with Marcin, who kind of, you know, in 4 years, he was transformed from an engineer to a researcher. So this was a very nice, you know, journey. What can I tell you about Marcin? As you've seen, he's a great presenter. So he was always very prominent in the conferences we attended. In where? In Italy, in Seoul. Soon he's gonna go to Hawaii. So he's been traveling a bit, and every time he's, you know, he makes an impression, right? He's very confident and he talks about provenance and RDF, so he's well known now in the community. What I can also tell you, which he didn't tell you before, is that he has an amazing publication report, which for me was kind of important, right? It's the publish or perish system, and he did not publish in any, you know, average conference. He always published at the top conferences. So he has 2 papers at WWW, the World Wide Web International Conference, which is kind of the biggest conference in our field, at the main track, the research track, which has an acceptance rate of 10%. Right? So you send the paper there, you send the best work there, and 1 out of 10 papers gets accepted. So Marcin has 2. So since those are, distinct events, you can kind of multiply the probabilities and see what's the likelihood of having 2 papers there. He has 2 papers at ISWIC, which is the top semantic web conference, 1 paper at VLDB, which is the top database conference, and soon 1 paper at TKDE, Transactions and Knowledge and Data Engineering, which is the top paper in data management. So I think it's a great achievement. One more thing which you might know if you know Marcin, he's a great organizer, right? So he was always organizing all kinds of events for the lab. In 2 weeks we will go to Rome for a small retreat. It wouldn't have been possible without him. So that's what I can, that's what I can say about Marcin and his work. Excellent student, really had this progression. So congrats. Let me tell you now a bit about his dissertation and the exam we had on Monday. There too, we tried to get the best people to kind of, look at his work and tell us what they think about it. So we had the best president, Marino, who was the MC on Monday. We were very happy that Beat also accepted to be a reviewer. And we had two external reviewers. Professor Dr. Manfred Hauswirth, who is a very well-known person in RDF. He's a professor at TU Berlin, and he's the the director of Focus, which is the largest IT research organization in Germany. And we also had Paul Groth, Dr. Paul Groth, who is the head, basically, or the main researcher at Elsevier in Amsterdam, and who is the author of this provenance standard we talked about. So we had the exam, I think on Monday, was it correct, or Tuesday? Tuesday. The jury asked tough questions. Marcin could answer all those questions, and in the end, the thesis was accepted without reservations. So, Marcin, it is my great pleasure today to give you this certificate for PhD, which will grant you the right to be called Doctor Scientiarum Informaticum. Informaticarum. Sorry, my Latin is a bit not Polish, So, Dr. Wylot, congrats.
The only thing I can say, thanks a lot, Philip, for supervising me. Thanks a lot for giving me this chance. It was a huge pleasure, huge opportunity, and I did my best not to disappoint you. Thank you very much for coming here, for being here, for listening to me. And let me now invite you for a small glass of wine.